Right, everyone. So I will be doing practical of site-to-site IPsec VPN between a Palo Alto firewall and a Cisco iOS router. Now, my ready. So I have a Palo Alto firewall which is connected with an ISP. He is acting as an ISP router. The private network consists of a multi-layer switch which connects with R1. Happens to be the private host which is in VLAN 101. Of 170.16.101 is used for VLAN 101. We would like to connect R1, which is VLAN 101, with the private site connected on R5, which is 192.168.100.0. Now, this remote site on R5 is simulated by a loopback interface. See 192.168.100.0/24. This is a loopback interface on which basically simulating the remote site. I have done earlier series of the site-to-site VPN and IPsec. How does it work? Okay. So I would not be using this particular video for discussing about how the IPsec standard function, different options of IPsec function. Well, that's not this video is all about. This video will be specifically focusing on the configuration and the troubleshooting of site-to-site VPN between a router and a Palo Alto firewall. So that's focus. Now, a few things I'll just sort it out over here. So we are running OSPF internally. So is running OSPF internally with multi-layer switch as well as R1. And the Palo Alto firewall is generating a default route so the private host can reach it using the firewall. So, let's use the Palo Alto firewall. On the management IP of 57. Default anyway. Let me show this to you on the multi-layer switch tables. This 10.10 is basically the Palo Alto firewall. If I see the show IP route command over here, last resort 170.16.80.0 connected. So then basically is a Palo Alto firewall IP address. This is the IP address of Palo Alto firewall 80, which is with the multi-layer switch. So generating a default route as you can see. OSP of the default is injected as an external route. The gateway class resort is set over here on switch 1. And one is subsequently passing this information to 1. So on the private network 101 or connected to the switch can reach internet because of the default route is available. Default is pointing towards the firewall. Now for that, the Palo Alto firewall is having a static default route pointing towards the service provider, as we normally do. Normally configure a static default route pointing towards service provider. Option will be to use BGP. Well, it is suggested to go for BGP until you have specific requirements. So many people do. We have a specific static default route pointing toward 3. The IP we are using between the Palo Alto firewall and router 3 is 136.123. Okay. Let me just quickly go to the CLI of Palo Alto. I have an SSH access to Palo Alto firewall. So look at the routing over here. So I have a static default route which is pointing toward 166.1.123.3, which is basically the routing 3. And supposed to be the ISP router. I'll also be able to ping it directly connected. About the firewall, you need to mention the source IP and the destination we are trying to access is. So that's working. So we have direct connect with the ISP. There's nothing complicated about this part. So the firewall should have access to ISP, because if you do not have access to ISP, the tunnel will not work. 5 is using a public IP of 161.100. So over here between R3 and R5 we're using, let me just put it over here. So we're using 136.100.6. So that's the public IP which R is using. R5 is also having a default route pointing toward the local service provider, which happens to be R3. So we can static default route pointing toward R3. And since both point of firewall as R5, static default route pointing toward 3, well, you should be able to have public IP reachability from R5 to forward. The public IP reachability is something which a service provider is responsible for. We don't have to do anything in that area. We are expected to have a public IP to public IP reachability. I'm going to ping from R5 Palo Alto outside ISP interface IP, which is 136.123.10. So 5. I try to ping. Okay. I have public IP to public IP reachability. That's an issue. We have all the fundamentals covered over here. The basic connectivity is covered over here. R5 has the default route pointing to a service provider. R5 is having reachability up to the public interface of Palo Alto firewall. And the private users are getting a default route, or you would not be able to access internet. So that is also in place. Now the idea will be to create a static site-to-site tunnel between R5 and Palo Alto firewall. Let's see what objective over here. So I'd like to create a site-to-site IPsec between router and Palo Alto. Parameters for phase 1. Now I expect you to be aware of IPsec, how does it work. So the phase 1 and the phase 2 parameters, basically we configure. We're using IPsec version 1. Okay, work with IPsec version 2. So these phase 1 parameters. Now phase 1, to brief you, is basically direction. IKMP protocol will be responsible for the negotiation. Both the devices will be negotiating their parameters. Okay, and these parameters which we need. Well, what happens is that IPsec is supposed to be an open standard, but when it comes to two vendors, parameters can be different. Like the lifetime also router being used is 86,400 seconds, which comes to 24 hours. But maybe the Palo Alto firewall may have a different parameters. So look at multi-vendor deployment of IPsec VPN. You need to be aware of how these things function. Okay, a bit of a problem. The objective today practical is to highlight all those things as well. So these are the phase 1 parameters. So I'm using AES 128. Authentication we're using pre-shared key. Let's give it a business for 123. Group we are using 5 and the lifetime. Okay. Phase 2 parameters. Now in phase 2 basically IPsec come into picture. Phase bidirectional, it is 0 direction. So we have 2 security associations created. One inbound, one outbound. The inbound security association will be decrypting the traffic based on the interesting traffic policy, and the outbound SA will be responsible for ending the traffic and sending it over the tunnel. What is going to be encrypted, what is going to be decrypted is dictated by the proxy ID or interesting traffic ACL. So this is supposed to be the interesting traffic which we are going to have between the Palo Alto and the remote site. So the local private site is going to be VLAN 101, which is private IP of 172.16.101. The R5 is host other remote location, which is 192.168.100. So what we want to do, let me just give you some basic settings I'm having over here. I come to my virtual router. Okay, a few interfaces. Have this is a private interface, /1, okay, which is using 1680. So this is right over here. between the firewall and the switch. The E3 is supposed to be connected to internet. So that's between Palo Alto and R3. Now, D is not going to be used in this scenario, so I'm not skipping that. Coming to my routers. So let's have a look at the routing configuration. Palo Alto. You have a virtual router by default. You create multiple virtual routing instances. This I was working with VRS. So these are the interfaces which this particular default virtual router is using. I have a couple of static routes. Actually, I have one static route. So route pointing toward the service provider. This is the default static route. Route interface E1/3. This is the next hop, 123.3, which happens to be router 3. Static default route on firewall. Okay, that's what we need. Now, remember one thing, that if you do not have static default route, you cannot attach a default route into OSPF. So it works similarly on Cisco router as well. So you've got a default route pointing to a service provider, and then this route will be injected in OSPF. So for Palo Alto firewall as well. Covered. I have the static default route. What we do is, I'm going to start with the configuration of site-to-site VPN on R5. So I'll configure the parameters on R5 first, and then we'll come to Palo Alto firewall. Again, a real setup, you don't have to really worry about public being able to connect with other public IP. You might a public IP to public IP reachability in a scenario, unless something is wrong with the service provider. But think of a lab. Okay, things for granted. You are creating a service provider. You ensure the end-to-end reachability. So have tested the reachability between the public IP of R5 and the IP of firewall. If you have this reachability, the tunnel is anyway normal. As you can see, I have pinged the IP of Palo Alto firewall, which is 136.123.10, and I'm able to ping it successfully. So that's the thing which you should check before you start working on your VPN labs. Okay, that's the minimum you should be looking. That is that. Let's start the configuration. Just a task list to suggest. When you start configuration of IPsec VPN, basically it works like this: that you need to configure phone parameters first, and then you configure phase 2 parameters. So, irrespective of which firewall product you are working on, which vendor you are working on, the logic of VPN configuration should not change. What is your phase 1 parameters? Configure that. What is your authentication method? Initiate it simple. If the digital certificate, well, you'll need to register yourself and get the certificate downloaded on your system. So whichever method you might be using, the logic remains here. Then the phase 2 parameters. Now, phase 2 parameter primarily looks at for two things. What will be the phase second encapsulation? Well, the encapsulations are ESP and AH. Both are protocols. ESP protocol number 50. We will not be using AH because it does not allow encryption. It would be very rare to see AH being used for VPN. So naturally, the choice is going to be ESP. The second thing is, in phase 2, you need to tell the system what will be the interesting traffic, which traffic is supposed to bring the tunnel. What happens is that your internet link is going to have two kind of traffic now. You have one traffic which is going to go to internet and is going to be in clear text. Other traffic which is supposed to go to the tunnel, okay, that is supposed to be encrypted. The phase 2 parameters tells the firewall or router what actually is the traffic which is supposed to go through the tunnel, traffic which is supposed to get encrypted. Alright, so it's like you are splitting your physical internet connection into two virtual circuits. So it will be all internet traffic which is supposed to go in clear text, unless and until you are having some end-to-end encryption like SSL, etc. But firewall is not going to do any encryption that scenario. Okay. The thing is, when the proxy ID is matched and firewall understands this is the interesting traffic, now the VPN kicks in, and this traffic has to go through the tunnel. Anyway, it has to be encrypted. It has to be encapsulated, hashed, so on and so forth. So this is supposed to be the interesting traffic. Yes, this is going to be the configuration. So out of the configuration is pretty simple. We'll start with the phase 1 configuration. I told you that phase 1 configuration, responsibility of Isaac, basically a protocol under the IKE. Okay, used by default UDP port number 100. And in between two basic devices, you will switching to 4500 UDP port. So let's say the policy with any number, the lower the better, and options. These are the phase 1 parameters which we are we configure on a system program. Right? So my authentication method is pre-shared key. My encryption is the AES. Okay. By default is 128 unless or until you select 192 or 256. So if I select anything, it will still take 128. Okay. Hashing, we are using SHA. So that is taken care of. Group, so VPN group, 645. Okay. Operating system which you have, you will get more options. Going for VPN group 5, and let's see what we have done so far. So yes, mention lifetime. Okay. If you wish, you can do that. Lifetime of the keys which you are exchanging, the VPN keys. Okay. Cisco uses a default of 24 hours, which is 86,400 seconds. That's what we need as far as the task is concerned. Second, that's good. But keep it default. I'm going to keep it as it is. I'm not going to touch this. Okay. Crypto Isaac. Isaac KMP policy. So we get the policy 1, which we created using the following parameters. Well, everything else is we have configured. So all these are our parameters, except one. The lifetime of 86,400 seconds is taken by the system. Also, a default protection suite, a default profile is running the system. So we need to create a profile. This default profile is used. We'll be careful about the default profiles because they can vary from product to product. Okay. Show you the Palo Alto firewall also use a couple of default profiles, but they not be able to match this one. Okay, what's on this particular IMS, right? So the things which you need to worry on in multi-vendor deployment. Right, my phase 1. Now, since my authentication is pre-shared key, so for phase 1 authentication, okay, I'm 0. That means I'm not going to keep this password encrypted on this particular router. Okay, and address of the device or IPsec peer is a Palo Alto, right? So Palo Alto is using the address of 136.1.123.10. That's what I'm going to use. Okay. That's my key for a particular peer for phase 1 negotiation. All right. So with what we are done with phase 1 configuration, we have phase 1 authentication information. Now switch to phase 2. So when you work with phase 2, it's pretty simple. The commands will be IPsec. Okay. So when this IPsec, you're automatically looking at the phase 2 configuration. So say crypto IPsec, I'm going to create the transform set. Okay. But like the policy for phase 2. So if I check options over here on Cisco router, I get AH. Right. That's not something which we're going to use. So I'm going to use PAES and I'm going to use ESP sharp. Okay. HTML for message authentication. So this is going to be my phase 2 policy. You can mention it mode as tunnel transport. It is going to be tunnel and side-to-side VPN by default. And just keep in mind that whenever we're going to use 2 headers, it's going to be tunnel. It should be host to host mode. So that you're working with JRE, etc., it's not going to be transport. Okay. We have configured the phase 2 parameter. Now, the most important part, and this is where the maximum troubleshooting occurs, the interesting traffic. This is the traffic you wish to put on the tunnel. Or say that way also that this is the traffic based on which the tunnel will come. The permit IP, okay, on R5, the source is 192.168.100.0. Okay, the destination is 176.1.0. I'm telling my firewall, when it comes to encryption, source and the destination. Traffic coming from the source, this particular destination, you're supposed to do encryption. Decryption. So you're supposed to decrypt. Once when you use an IP parameter, okay, the firewall is going to reverse it. There will be an invisible statement added to your access list, which says when the source is 176.1.1 and the is 192.168, you're supposed to decrypt it. How using TCP with port numbers or UDP with port numbers, then it's going to be slightly more complicated. So I don't want traffic, because when I IP, it's going to be like in traffic going between these two. Let's say, assume I have a customer who is only looking to send TCP traffic over the tunnel. So the TCP and the destination port number is 80. So if you produce TCP, the destination port number becomes 80. It comes with the reverse traffic. Okay, traffic is supposed to encrypt. One is supposed to decrypt to the web server. That can slightly challenging, slightly more complicated, right? So we cannot do it, but generally we suggest clients to use IP for the sake of convenience. So I'm done with the policy configuration on Cisco router out of 5. Right? This is my interesting traffic. Now we put everything together in crypto map. So I'm going to use sequence number 1 over here, IPsec, ISEC, MP. I'm going to put everything over here. So set peer, my peer is 136.123.10. That's my Palo Alto public IP. Set transform set, which is pset. Okay, my phase 2 policy. And watch traffic. Okay, so match this traffic. This is the traffic I'm supposed to match. Okay, this is the traffic which is going to come, bring up the tunnel. Finally, you need to put the crypto map on the public interface. Just remember public interface. Okay, go to FA050 and put crypto map over here. Now, the moment I do that, the ISEC MP will become enabled, as you can see. If you have any hardware-based modules, sector of encryption, decryption activated. Okay. And the second thing is the crypto map is like a filter. So this is decide which traffic is supposed to go encrypted, which traffic is supposed to go in clear text. So that's what crypto map is going to do. Okay, note of it as a traffic selector. So going out of this interface, crypto map is going to check, and the traffic which is received on this interface, crypto map is going to check whether it's supposed to be part of the tunnel. So we are done with router 5. Okay, let's quickly have a relook at the configuration. I configured phase 1 policy. You don't see SHA. Okay, that is default. So what is default parameter? You will not be able to see that. This is my phase 1 authentication key. So 1, 2, 3 with this peer. This is my phase 2 policy. And crypto map VPN with all these parameters. Okay. I'm in part 1 now. And next year I'm going to look at the configuration of Palo Alto firewall.